here's what we're going to do. Marley, I'm waiting. Marley, I'm waiting. Thank you. All right. Today, guys, we are going to, part of your math today is related to kind of a review before we do our final test for division. And some of you have said that the division is a little hard, and I agree. It is not the easiest lesson in our unit that we've done. So what I want to do is kind of go through one more review of the 3 different methods that we can use for our division. So I wrote these up for us. Our first method that we've gone through this unit is called the place value method. I'm sure this one's familiar for you guys, where if we were to take the problem 8,435 divided by 5, we would use the box here where we draw the initial number in. So we put the initial value right here. And I was thinking in terms of this. When we are thinking of numbers, you guys know these numbers very well. When we talk about 5 times 1, what is that? 5, exactly. That was easy, right?
Yeah.
So that makes, your knowledge of that makes this even easier.
50.
How'd you know that, Claire?
Well, I did 5 times 1 is 5, and
Right.
then you add a 0 from the 10.
So then if you did that, and Claire, thank you, I appreciate your help with that. Can someone else help me figure this out?
100.
Kate,
5.
how'd you get that?
I got it by taking away the 2 zeros and 100, which is 5 times 1, so that's 5, and then I added the 2 zeros back.
And then you put those 2 zeros on the end, right? So then, let's do one more. Can someone else help me with this one?
5,000.
Troy,
5,000.
how'd you get that?
Because if you do 5 times 100, you just add a 0, and that will be 5,000.
True, that's more, I like the way you said that, and going back to what Kate was saying earlier, here all we have to do is see, again, is 5 times 1, right? To get that 5. And then how many zeros did we ignore?
3.
3, we put those 3 on to get our 5,000. Okay, so going with that information and that knowledge, I want to go back to that place value method that we had before and look at this. I picked a number that I knew pretty well. I call it a pillar number because it's a number that's kind of a key number in helping us solve math equations. And I knew that 5 times 1,000 made 5,000. So I put the 1,000 up here, and when I subtracted that, I still had 3,435 left. I transferred that 3,435 up here, and then I asked myself, well, how many would I have to multiply times 5 to get 3,000? Well, I know 5 times 6 is 30, and then put 2 zeros on would give me 3,000. So I used 3,000, subtracted that, and I had 435 left again. Now I asked myself, what number would I multiply to make 40? Well, that would be what? 5 times 8 would make 40, so if I put one more onto that, that gives me 400. And when I subtract 435 minus 400, I had 35 left. So I transferred the 35, and then I said, well, 5 times what equals 35?
35.
7. Okay, thank you, Abby. So 5 times 7 equals 35, and all I have to do is subtract that to get my 0. Now I can take these numbers up top here, and all I have to do is add them together. So I add my 1,000, my 600, my 80, and my 7 to get my final answer of 1,687. That's one method that you can use. Okay? This is just the same as any other tool that I've given you, where you don't have to do it the way that I show you, but it's just one more tool in your tool set. Another one is what we call the expanded notation method, which I've seen some of you guys use in class, where we take the 5 and we take those same numbers and we say, well, what number times 5 would make 5,000? Claire?
1,000.
1,000. So I put that 1,000 on the side here. I subtract the 5,000 to get 3,435. Then I did the same thing again, where I said, well, 5 times 600 would give me 3,000. And when I subtracted that, I had my 435.
So it's the same thing in a different format?
Well said, McKenna. Exactly, you're right. It's the same thing, just laid out in a different way. Okay, so here we came up with the 400, and that left us our 35 to do 7 right here. And then all I had to do is add those up to get the same answer. Now, this is the traditional method that your mom and dad and I were taught when we were your age. So this is the way that we were told to do it. We always used to say, well, how many times does 5, and here's the key words I think throws a few people off. When I say the words, how many times does 5 go into 8? What do I mean when I say go into? What do you think that means, Abby?
It means how much 5 can make to 8
Before it
goes over 8.
Well said. So how many 5s can I add together before it goes over 8? Troy?
1.
Only 1 in this case. So I put the 1 up here, and I subtracted that 1 5 to get 3, and then I knew, well, 5 can't go into 3. It's too big, isn't it? So I had to borrow a number, and I brought the 4 down to make 34. Can 5 go into 34?
Yeah.
Okay. Can I multiply a number times 5 that would be either equal to 34 or just less than 34? What do you think, Elia?
7. 6.
5 times 7 would make what?
35.
35. Is that too much for 34?
Yes.
So what would be the next number down?
7. 6.
6. Exactly. So it would be 6. So we have 6 here, and I know 6 times 5 will give me 30. When I subtract that, I had 4 left. Well, I know 5 cannot go into 4 because it's too big.
So the answer is 5 or 4.
So I brought this 3 down
Or not.
to make 43. Can 5 create a number that's less than or equal to 43? Okay, Sophia?
It can do 8 times 5.
So I know 8 times 5 makes 40, and when I subtracted that, I had 3 left, and I know 5 cannot go into 3, but I brought this 5 down to make 35, and we know that 5 times what, Elia, makes 35? 7, and that's our final number. So that is the method that actually your mom and dad and I were taught how to do division.
Wait,
And
how
that
did you get the 8?
Notice that, how did I get the 8? Because I know that 8 times 5 makes 40.
Oh.
Okay?
Oh, yeah.
So all 3 of these methods came up with the same answer. Today, what I'm going to do is give you an assignment where you're going to be reviewing some 3-digit numbers. I want you to use any one of these 3 methods that you're most comfortable with. All right? Can everybody please go back to their seats?